Hey guys, thank you so much for joining me for my very first video today. Today I'm going to be covering the basics of trig. So what exactly is trig? Trig is a branch of mathematics that studies relationships and I know you guys can't see the whole text right now, but I will bring it down in a second. But yes, it's a branch of mathematics that studies relationships between side lengths and angles of triangles. And this may not make complete sense yet, but we're going to keep digging in and explaining trig, so I'm sure by the end of this video you will get the basics down completely. Now, before we start jumping into an example, I want to explain some things. First thing being, and honestly one of the most important things when it comes to trig, is that you can only use trig when you are applying it to a right triangle. Now, what a right triangle is, in case any of you don't know, is a triangle with a side that measures 90 degrees, okay? So please remember that. And then the next thing I want you to know is that there are 3 functions in trig, and those functions are sine, cosine, and tangent. Okay? So remember that too. And the way you can remember these functions and what they apply to is through an abbreviation called SOHCAHTOA. Now, let me explain what SOHCAHTOA is exactly. So the S in SOHCAHTOA stands for sine, the C stands for cosine, and the T stands for tangent. Now you may be asking, what exactly does the OH, the AH, and the OA stand for? And let me explain. So the O stands for opposite. The A stands for adjacent, and the H stands for hypotenuse. And I'm just abbreviating all of these because it's just quicker. So I also want to mention, before we get into an example, although we are almost there, that when you are referring to the sine, cosine, and tangent, you're referring to an angle measure. And when you're referring to the opposite, adjacent, or hypotenuse, you are referring to side lengths. And that's why the definition, if you look back up, says, oh, I'm so sorry for the messy handwriting there, but you'll see that the definition says studies relationships between side lengths and angles. So the side lengths are right here. Oh, I'm so sorry. The side angles are right here, and the side lengths are right here. So let's start off with an example, and I'll walk you through it, and I will just go through explaining everything. So, like I said, please remember that trig is only done with a right triangle. So if you draw a triangle like this, which has clearly no right angles, you can not do trig with this triangle. You cannot do trig, okay? So you must use a triangle that has a right angle similar to this one, and it's not perfect because I did just draw it, but you guys get the idea. The right angle is right there. So when you are solving for trig, there are 3 elements in the triangle that are very necessary. An angle besides the right angle, because you actually do not use the right angle to solve, but I will explain that a little bit into the example. Then you need a side length that you are trying to solve for. And then lastly, you need a side length given to you besides the one you solved for, or you will solve for, because you have not solved it yet. So please remember these 3 things. So because I am just making up this example, I'm just going to add these things into the triangle real quick. So let's give this triangle a side length here of, oh my gosh, my handwriting, you guys, I'm so sorry, of 36 degrees. And then let's say we want to solve for this side right here. So that means that we have given an angle besides the right angle. We have chosen a side length that we are solving for. And now the last thing we must do is have a side length that is given to us besides the one we're going to solve for. So I'm just going to call this side length 15, yeah? So that means that we have all 3 elements that we need to solve for trig. So let's just jump right in. And I want to refer back now to SOHCAHTOA. And it is on this last page right here, but I will go ahead and rewrite it on the new page as well. SOHCAHTOA. I won't write what each thing means because once again, I did write that down on the last slide and we can just go back and refer to it whenever we need to. So let's figure out what function we need to use to solve the side length of x. Do we need to use sine, cosine, or tangent? Because remember I said back here that the S stands for sine, the C stands for cosine, the T stands for tangent. And you may be asking, well, how do I know? Well, this is how. So you go ahead and look at the angle that is given to you besides the right angle, which in our case is this 36-degree angle. And then I do want to say that this is quite important. I forgot the degree sign, but yes. And so we're looking at this angle that's given to us besides the right angle, which is this 36-degree angle. And then let's start off with sine, just because it is first on our list of SOHCAHTOA. And what does sine include? We can go back and look at our last slide. Sine is followed by an O and an H, which is opposite, right here, and hypotenuse. Yes, because the O stands for opposite and the H stands for hypotenuse. And so then we're going to go ahead and look what is opposite of this 36-degree angle, and it's our x, which is the side length we're solving for. And remember, it must include these 3 things. So does opposite include the side length we're solving for? Yes. And then what else do we need? Our hypotenuse. Is our hypotenuse given to us? Yes. So it seems that sine would be good to use for this question. But because we are just learning the basics, I'm going to go through cosine and tangent as well, so you can get an understanding of what exactly we're looking for in each function of trig. So Then we check cosine, and then as you see, cosine has a and h following it, meaning you have to look for adjacent and hypotenuse. And so the adjacent side is the side next to the angle besides the right angle, whichever angle you're solving for. So it's not the hypotenuse, which is always the slanted line, and it's not your opposite angle, it's the one that the angle is connected to. And I'm so sorry, I realized I misspoke. It is not the opposite side length, it is the side length that your angle is connected to. So if we're using cosine, we go ahead and we check that side length that our angle is connected to, and nothing is given. It is neither the side we are solving for nor the side that is just given to us. So honestly, that automatically rules out cosine, because one of the factors, a and h, a is not given to us, so we cannot solve. And then we'll go ahead and look at tangent, which includes O and A, which is opposite and adjacent. So we're going to look at our side length opposite of the 36-degree angle, which is x, perfect, and then adjacent, which is this one, and it is not given to us, which we established when we were looking for the adjacent and cosine, meaning since one of O and A are not given, we cannot solve using tangent either. So our only trig function that we can use to solve this question is sine. So I'm just going to go ahead and show you how to do that really quick. So remember how I said back here that the sine, cosine, and tan is referring to the angle. So the reason I said that is because when you're writing it down, and remember, we're using this angle right here that was given to us besides the right angle. So you're going to write sine of 36 degrees, like that, equals, and then it includes OH. So you're going to write it as a fraction, and you're going to write x for opposite, because that is what is opposite of our angle, and then 15 for hypotenuse, because that is the length of our hypotenuse. And just like any algebraic equation, when you're solving for x, you get x alone on one side. And how do you always do that? By multiplying on 15 on both sides, or just multiplying on both sides. So there's not much room here, but I'm just going to try to squeeze in this 15. And just know it goes right here. And so I'll rewrite the equation now that we've multiplied on both sides, and that is 15 sine 36 equals x. And you will not be doing this in your head or on paper. You do need a calculator for this, and any scientific calculator or even calculators on iPhones, they have trig functions, so you can just go ahead and plug it right in. I won't do that for you because you now understand the basic process, and I'm sure you guys can plug it in on your own. But those are the basics of trig, and I'm just gonna summarize really quick. Remember that you can only do trig with a right triangle, but the angle that you are using while solving for trig is not the right angle, it is the other angle that is given to you. And when looking for which function of trig to use, sine, cosine, or tangent, you must check the letters that follow it using SOHCAHTOA and make sure that those factors are given, meaning make sure that the opposite side length of your angle is either a side length you're solving for or a side length that is given to you besides the one you're solving for. And same thing with the adjacent and hypotenuse and all of that. Just make sure all of that information is given to you and just plug in like any normal equation. Put x alone on one side and solve using your calculator, and that is all trig is. And I know today I only went over one example, but I just wanted to cover the basics and introduce you all to trig today. And in my next video, I will be uploading a short video of 2 or 3 more examples so you can really understand and start flowing with the trig, and then maybe just go a little bit further explaining how once you solve for this missing side length, which by the way, in case it didn't click for some of you, is what we did here because we solved for x, so we solved for this side length. In the next video, I might even show you how to solve for this last side length really quickly after you do trig and solve for this one. So if you enjoyed this video, or if this video was helpful to you, please make sure to subscribe, like, and comment, and of course share if you don't mind. I will see you guys in my next video, and I hope this helped. Bye!